the human brain is an amazingly energy-efficient device. In computing terms, it can perform the equivalent of an exaflop. That is, a billion mathematical operations per second, with just 20 watts of power. In comparison, one of the most powerful supercomputers in the world, the Oak Ridge Frontier, recently demonstrated exaflop computing. But it needs a million times more power, 20 megawatts. Yet, since early days of technological history, computer scientists have strived to make machines as intelligent as humans. Welcome to The Why in History. I am Ajay Kaul, and today we take a look at artificial intelligence, its history, and its evolution over time. It was in the 1950s that we had a generation of scientists, mathematicians, and philosophers who conceived and assimilated the concept of artificial intelligence. The thought process here was that humans typically used available information and blended it with reason to solve problems and make decisions. And if that was it, why couldn't machines do the same? And British scientist Alan Turing pioneered this concept in his 1950 paper, Computing Machinery and Intelligence, where he discussed how to build intelligent machines and how to test their intelligence. The core premise of this paper was answering the question around, can machines think? And Turing went on to propose a method for evaluating whether machines can think. And this came to be known as the Turing Test. And there was strong opposition to the notion that computers could think. And it was driven by the Chinese room argument, meaning someone is locked in a room where they are passed notes in Mandarin, and using an entire library of rules and lookup tables, those were the best language translation tools available at that time. So using these lookup tables, they would be able to produce a valid response in Chinese. But would they really understand the language? Just because I'm able to use tools and provide an accurate translation does not mean I understand that language. And that was the challenge given to artificial intelligence. Can machines think and produce an intelligent statement based on questions or prompts? And this is exactly what the Turing test sought to evaluate. So the use case behind Turing's test required a man, a woman, and an interrogator. The goal was for the interrogator to identify which of the participants was a man and which was a woman. Now, since the interrogator would be able to identify the gender of the respondent by their voice, the answers to the interrogator's question would be typewritten or repeated by an intermediary. For the Turing test, one of the two participants would be replaced by a machine, and the Turing test would be considered successful if the interrogator were unable to differentiate between the human and the machine based on the responses. So has any machine passed the Turing test? Surprisingly, not one. Zero. We are now in 2024, and to this date, no machine has been able to pass the Turing test. The tech community feels that it is a software issue because the processor technology has improved leaps and bounds and the computation ability has improved. So information processing does not seem to be the issue. The gap seems to be the inability of the machine to apply logic on the information processed and provide a thoughtful and an intelligent response. So with Turing laying out the basic infrastructure for testing the intelligence of machines, the world became obsessed with creating an intelligent machine. And the first target was chess. Could a machine play chess? In 1950, Claude Shannon, a mathematician and computer scientist from MIT, published a paper called Programming a Computer for Playing Chess. The paper described two approaches: Type A programs, which would use brute force and examine thousands of moves and narrow down on a specific move, or Type B programs, which would use specialized heuristics and strategic AI, examining only a few key candidate moves. Initially, Type B programs were preferred because in the 1950s and 60s, computers were limited with respect to the processing power. However, in 1973, as the computer processing power improved, the developers of the chess series of programs switched their program over to Type A. The new program was called Chess 4.0, and it went on to win a number of computer chess titles. Now, this was an interesting development, almost a regression, because as the computer processing power improved, the software engineers switched to the dumber version of the program, primarily because it was simpler to write. And as the computer processing power improved, the Type A programs could parallelize the processing and evaluation of the moves. Now, Type B would have been really the right step in the direction of true artificial intelligence, because you would be teaching the computer rules of thumb, strategies, etc. But all that was relegated to the background. And one of such Type A programs was IBM's Deep Blue. In 1997, Deep Blue challenged and defeated the then world chess champion Garry Kasparov. Though it did create a lot of hype for IBM, which saw its stock price go to an all-time high, the scientific community understood that it was sheer speed rather than intelligence that had beaten Kasparov. But almost 40 years prior to Deep Blue, an electrical engineering MIT graduate, Arthur Samuel, popularized the term machine learning in 1959. He built the Samuel's checkers playing program, which was among the world's first self-learning programs, and as a result demonstrated the concept of artificial intelligence. Self-learning. Wait, what is that? Self-learning essentially is the primary concept behind artificial intelligence, which means that the machine can train itself using unlabeled data. For example, it sees 2, 3, and then it sees 5. Then it sees 3, 4, and then 7. And slowly it begins to figure out that we are talking addition here. And this is achieved by analyzing the data set and looking for patterns. And that was the primary concept that Arthur Samuel was trying to present in his computer checkers game. He felt that just as humans gained experience through learning from their mistakes, computers too could be taught to analyze their output, provide them feedback on the quality of their output, and based on that, they could learn to self-correct and gain intelligence over a period of time. While Arthur Samuel implemented the basic algorithm to optimize the chance of winning at the game of checkers, he also designed various mechanisms by which the program could become better through repeated learning. The program remembered all the positions it had already seen along with the end result. And as a result of this, it constantly re-evaluated the probability of success on a specific position based on past data. And over a period of time, through continuous learning, Samuel's program reached a respectable amateur status, which at that time was very commendable. The next milestone in the AI journey happened in 1966 when another MIT professor named Joseph Weizenbaum created the first chatbot. The chatbot was named Eliza after Eliza Doolittle from George Bernard Shaw's play Pygmalion. The chatbot was cast in the role of a psychotherapist, so a user would type a message on an electric typewriter connected to a mainframe computer. And after a moment, the psychotherapist chatbot would provide a response to the user. Now, there wasn't much intelligence in this program. It was simply a set of rules that generated a plausible response based on certain keywords in the user's input. For example, if the user wrote, "My mother cooks good food," the chatbot would recognize the word mother and frame a response somewhat like, "Oh, tell me more about your family." Now, despite Eliza and Deep Blue not being very intelligent programs, they did generate quite a bit of hype around intelligent machines and the way these were getting better over time. But many years before Eliza, in 1958, Frank Rosenblatt built the Mark I perceptron at the Cornell Aeronautical Laboratory, which was using the artificial intelligence algorithm that is being used even today, the basic neural network. Neural networks, what are they? Well, scientists realized early that if you needed a machine to be as smart as a human, you probably needed to build an infrastructure that mimicked the human brain. Neural networks function as software simulations of the brain. So an artificial neural network is a computer program or algorithm that organizes billions of transistors in a computer to operate as though they were interconnected neurons in a human brain. Wait, how does that happen? The artificial neurons are mathematical functions which are executed on the direction of the program. These neurons are organized into three types of layers: the input layer, the hidden layer, and the output layer. So let us assume in our example, we are trying to recognize a handwritten number between 0 and 9. The input layer receives the information from an external source. In this case, it could be a video camera or an image that is hooked onto the computer. And the way the input would see it would be in the form of 784 pixels, 28 by 28, simply telling the network which pixels are lit and which aren't. The ones that are lit are essentially the outline of the number. The input received is then passed on to the hidden layers, and they're called hidden because they are not connected to any external source. The hidden layers will determine various characteristics of the image that they received from the input layer. For example, layer 1 within the hidden layer may try to determine if there are any edges. The second layer may try to interpret if there's any looping, and so on. And finally, we get to the output layer where the final result is delivered, meaning the digit between 0 and 9. So the answer could be 7 based on the fact that there was not much looping and mostly it was straight. So it may say, well, the number was most likely 7. This is known as a feed-forward network, meaning the information is starting from an input being sent forward to deliver the final result. And using this process, Frank Rosenblatt's Mark I perceptron was able to visually distinguish cards marked on the left side from cards that had been marked on the right. But almost 3 decades later, in 1986, came a breakthrough discovery of backpropagation. Geoffrey Hinton, a professor at Carnegie Mellon University, became one of the first researchers to describe what he called learning procedures. So a computer receives an input, processes it through the hidden layers, outputs it, and through a backpropagation algorithm receives feedback, which it re-inputs to refine its performance and update its knowledge. And it is this process that today is referred to as training the model. So all AI systems that rely on machine learning need to be trained. And there are three factors that drive the level of intelligence within that system. The first one is the input data being used for the training. The second is the computational performance measured in floating point operations per second, or flops, which is essentially the number of mathematical operations that the system is performing. And the third is the algorithm driving the learning. So with the advent of neural networks, computers reached a stage where they could perform image recognition and speech recognition. And then in 2014, Ian Goodfellow, a computer scientist, invented generative adversarial networks, or GANs, which took artificial intelligence to a whole new level. This gave computers the ability to generate photos, transform images, and even generate text. So what are the generative adversarial networks? So GANs are again a type of a neural network, but the difference is that we have two competing networks, a generator and a discriminator. The generator creates the outputs, and the discriminator tries to weed out the fake outputs from the real-world data. And with this back and forth process between the generator and the discriminator, the GANs can produce outputs that are pretty close to real data. And on November 30, 2022, OpenAI launched ChatGPT, which took this concept and applied it to text-based conversation, allowing it to engage in natural-sounding conversations. A new era in artificial intelligence was just ushered. And this is what is known as generative AI, which is essentially artificial intelligence able to generate new content. And the GPT acronym in ChatGPT stands for Generative Pre-trained Transformer. And the key here is that the generator is able to build a whole sentence by predicting the next word in a conversation. The key difference from the previous neural networks is that with GANs, the human feedback element is replaced by the discriminator. So both algorithms, the generator and the discriminator, help train each other. And the launch of ChatGPT suddenly woke the tech giants out of their slumber, and 2023 saw all of them coming up with rivals to ChatGPT. Google released Bard, Microsoft launched Bing Chat, and Anthropic, which is a startup, launched Claude. Out of these, the closest rival to ChatGPT is Anthropic's Claude, which has the ability to perform complex tasks like organizing huge chunks of text. Along with the euphoria, this also generated a lot of concern. And in March of 2023, a group of AI scientists and researchers called for a 6-month pause on all AI development. According to them, powerful AI systems should be developed only once we are confident that their effects will be positive and their risks will be manageable. The signatories to this letter included Apple co-founder Steve Wozniak, MIT professor Max Tegmark, investor Ian Hogarth, and Elon Musk. Well, it did not stop the development, but it did raise a genuine concern of the real and present dangers to the unmitigated development of artificial intelligence. And it is on that note that we end this section of the program. On to the quiz section. Question from the previous episode. What spice was the biggest revenue contributor in the European spice trade? Still the most traded spice in the world? The answer is D, pepper. Question for the current episode. In May of 2023, which prominent AI scientist quit his job citing the risks of unfettered development of AI? Was it A, OpenAI's Sam Altman, B, Microsoft's Eric Horowitz, C, Google's Geoffrey Hinton, or D, Anthropic's Jared Kaplan? Once again, in May of 2023, which prominent AI scientist quit his job citing the risks of unfettered development of AI? Was it A, OpenAI's Sam Altman, B, Microsoft's Eric Horowitz, C, Google's Geoffrey Hinton, or D, Anthropic's Jared Kaplan? The answer will be provided in the next episode. That's all we have in the current episode. In the next episode, we go a little investigative and look at the controversy around the Panama Papers leak. What was discovered and who were the prominent actors at the center of this controversy. Till then, stay safe and keep exploring the why in history.